Hey everyone. In my last video, I showed you that I was just setting up IPv6, and in that video there were a lot of IP addresses visible, and there were plenty of comments saying you shouldn't show IP addresses and all that sort of thing, even though they float around on the net. But anyway, just before I published that video, I started a packet capture on the WAN port of my router. Now my router is a Raspberry Pi, and that's one of the good things, is that I can just use TCP dump on that and capture stuff. So I did that, I've let it run for a day or so, and I'm just going to go through now some of the things that came in. And it's not really a Wireshark tutorial as such, just a couple of little tricks in Wireshark that you might not be familiar with on how to look at some packets. So anyway, I've got my hoodie on as it happens, which is apparently what all hackers wear, according to the media. So I'll show you what I saw. Okay, so here's the full packet capture from the day. You can see it's 2.9 gig. So I'm going to open that up, and being 3 gig, it's going to take a while to load. So you can see down here, it's going to take a while to load. I could make you wait, but I'll just skip through for you. Oh, actually, it's moving right along. But what I'm going to do is find the important bits that I'm going to look at, and then I'm going to resave just those and load that up again. So most of this obviously will be the traffic that I did throughout the day, and it's just nothing special. But what I want to look at is stuff coming in. So what I'm going to start with is TCP Sync. So that's tcp.flags.syn equals 1. So this is going to show whenever there's a TCP packet with the SYN flag, which is the start of a TCP session. So this time that it's taking, I don't want to do that when I'm doing other filters here. So what I'm going to do, since I'm only going to be looking at sync packets, I'm going to save this out once it's filtered this. Okay, so they're all SYN packets. So the first thing I'm going to do is go File, Export Specified Packets, which is different to saving the whole file. So down here, that would be all that would be all packets that I've captured, which is the whole thing, which would be pointless. But just the displayed ones here. So I'll just call this TCP SYN. So now I can piss that off, and Wireshark TCP SYN, just open that, and you'll see it's a lot quicker because the file's a lot smaller. In fact, how big was that file? TCP SYN, now it's 2 meg. So from 3 gig to 2 meg. Now I can juggle that around a bit easier. Now I'm not interested in the SYN packets that left my network, because that's obviously me doing something. I'm interested in the ones that were trying to hit my network to see if there was any open ports. So my address is the .16 address at the end here. So I want to look at ones where the destination IP is .16. So I'll just pick one and go down to the IP part down here, where the destination is shown as .16. Right click, apply as filter, and it brings up the filter for you. Now I know that, but if you don't know it, that's how you find it. Just click through down here. So now I've got all the packets that are destined for me, and you can see the source address is just random shit all over the place. What I'm interested in is to see if anyone was trying any port scans, where they just basically go through all the port numbers, the 65,000 of them, go through all the port numbers to see if anything's open, to see if they get a SYN coming back. Now obviously I've got everything shut at the firewall, so that's not going to happen. But I just want to see what patterns there are here. So first of all, I'm just going to see what the most common address is. So I'll just go up to Statistics, Ipv4 Statistics, and all addresses. And you can see even this has taken a little bit of loading time to figure this out. Now if I was doing that on the 3 gig file, it'd take forever. So anyway, here's all the addresses involved, and I'll just sort them out by the number of them, or the count. Okay, so the first one's me. Now the second one here, that is 8% of all these packets. So I'm going to have a little look at that. So what I'm going to do is I'm going to put that as the IP address up here. So IP address equals 104.156.155.10. So there we go. There's all these SYN packets coming from this address. Now the first thing that jumps out at me here is that the source port is the same for all of these packets. That's very odd, because every time you do a new comms session from a host, it would pick a random port above 1024. But this is the same, so that's straight away tells me something's being constructed specifically here. But I want to have a bit of a look and see. So you can see the time when these came in, it's all over the place. But I want to see the time between each packet. Now it's a little hard to see here. You can see that's roughly 2 seconds to that one, and this one you have to start seeing, okay, that's 59 seconds to that, but it's hard to work out. Well, down here, if you just go to the frame part, you'll layer 1 bit here, you'll see there's a time delta from previously displayed frame. That's what I want. So that one there, if I click the next one, you'll see it says 1.4 since the last one. There's that 59-second one. Well, I want that up here. So what I can just do for that field, just right click it and apply as column. So now I've got a column here for that field. So I don't really need that open anymore. That'll keep opening when I click on it. So you can see these times now between each frame, each packet, and they look very random. Like, it's not a uniform pattern. It's certainly not smashing them all one after the other. It's really taking its time and doing things all over the place. Now these ports, the destination port that it was trying me on, I want to see that as well. So down here where the port is, so that's layer 4, go to the destination port. That's what's written up here, okay? But I want that as a column as well. So I'll apply that as a column too. So you can see the destination port nice and clear. And the reason I wanted that there and not just look in the info is because I can now sort by this. So if I click on that destination port, I mean, it's doing them in kind of human numbers. You see 104 before 104.07. But you can see, if you can see what I can see, is that it's pretty much going through them all. So 57, 58, 9, 60, 61, 62. They're trying them all. And they're trying them at random times to try and be sneaky. So that would probably get past some intrusion detection system that looks for patterns, because it seems random. Even though I am surprised their source port's the same for all of these. That surprised me, to be honest. So anyway, this source is trying something. So I'll have a look who that is. Now if I look that up with dig and do a reverse on it, it doesn't actually show me much. So I can't see much about that. So let's see what else is interesting. After that one there, you see these two, and what I notice here for the next two, their IP addresses are somewhat close. They've got the same /24 at least. So I'm going to look into them now. So anyway, that shows that there's things going on there that is just what you'd call background noise, but you don't get to see it unless you do packet captures. Now, if you're doing a packet capture on your WAN port, you can start having a look. Now, it's really not worth losing sleep over. If you've got it firewalled off, this is going to happen. There's nothing I can do about the fact that these attempts are coming at me. That just happens on the net. You just got to firewall them out. And that's why on my firewall for my WAN interface, I've got them dropped. So that's both the input hook and the forwarding hook. So anyway, that's all I can do. But I just wanted to show you a couple of things in Wireshark, basically how to pluck out the relevant field that you want down here and put it as a column, because that way you can then sort by it and you can have a look around. So anyway, that's all I want to show you. Now if I look at IPv6 stuff, don't forget that's the layer 3 protocol. So that is what in layer 2 it will say the payload is, saying it's IPv6. So layer 3 is IPv6. But layer 4 is still the same, so I'm still looking for SYN packets, which is the file I saved. This time IPv6. So I don't know who's who. Again, I don't want the outbound stuff, but I'm going to do this via MAC address because I know it's going to be coming towards me. So same sort of thing. If the destination is, okay, there's one coming towards me. So the destination address is my Raspberry Pi. Apply that as a filter. Now I still want the IPv6 to be there. So this time I'll apply as a filter and selected. So ... means whatever I've got up there already, ... and selected. So it's kept my old one and it's adding this to it. So these are all things in IPv6 coming at me. And there's a few of them as well. So let's have a look. IPv6 statistics. Haven't done this yet in IPv6. So let's have a look. Do the count again. Now the first one's mine, so this will be the second one. So there's the IPv6 version of what I saw before, which again is a fairly high percentage of traffic. So I want that address, but if I copy, it copies this whole damn thing. So what I've got to do there is paste it in here, and then just copy the address from here. It's a bit of a pain. But anyway, so IP.address equals that much, IPv6 address equals that, and now we see what that is. And I'll do a reverse lookup on that, even though I don't like my chances. So dig-x, big address, see if anything comes back. Okay, so what's that thing doing? It's doing them all immediately. Okay, I'm just going to sort this by normal packet order here. And what can I see? Synac. Now what you can see here is traffic flowing in both directions. So there's something to 443 coming back to, I assume that's me. Yes, that's coming back to me. So I'm the one sending the SYN packet out and I'm getting a SYNAC back. And the reason that's coming in is because all I did was a TCP SYN for this whole file. So whenever there's a SYN flag set, where are we? SYN there, it'll come back. Some of them will have an ACK, some of them won't. So if there's a SYN ACK, that's what I expect from my return traffic. But if the traffic's starting from the internet, it won't have the SYN ACK. So what I'm going to do now is have something that's, I'm going to make it to make sure it's coming at me. So that's my address. Where are we? So Ethernet address, destination me. Let's just do this from the start. Okay, so that's my destination address. Now I want, well, the whole thing is SYN packets, but I don't want acknowledgements set. So apply as filter, I'm going to and not selected. So there you go. There's only a handful of them. So it really is bugger all. So IPv6, and that have a lot of addresses to start doing port scans around the net, but at the moment it's, what do we got? 6 over a day. So that's not too bad. And where did they actually come from? Let's have a look. Apply as filter. So that's there. The only reason I did that is so I can just copy that easily. So I'll do a quick lookup of that. -x, that thing. Who we got? Who the hell? Ah, IRC. Because I'm on the I'm on that IRC server. It's doing that. So cool. That's okay. That's expected. So that's that IRC server that I hang around sometimes and see what's going on in the world. So that explains that. Okay, that's it for now. Just a little video to show you what I've been up to. I do recommend being able to do packet captures and having a look, because really that's the only way to see stuff. You'll see what's on your network and you'll also learn a lot. So that's why I live on packet captures. Anyway, that'll do for now. Till next time, take it easy.